What happens when the object is located very, very, very far away? What type of image will be formed? Now in this example here, we're going to consider an object that's located very, very far away, so far away such that by the time the light rays comes closer to the lens, the light rays actually appear parallel to each other. So whenever you see parallel rays, you can always take it as, sorry, should I say when you see parallel rays flowing from very far away to the lens, you can take it as the object is located very object is located very, very, very far from the lens. Okay, very, very far away. Now, as you can see here, as you can see in this diagram, there's still the three basic lines apply, right? You have one line that's parallel to the principal axis, but in this case, instead of drawing from the object to the lens, we drew it from the image to the lens. This is the parallel line. So the three basic lines still apply. And the next line is from the lens through the optical center. Sorry, from the lens through the principal focus. So one parallel to the principal axis, the other one from the lens through the principal focus, and the last one, instead of from the object through the optical center, this time around we have from the image through the optical center. So the three basic lines still apply. And using the three basic lines, as you can see in the diagram here, see the image is formed on the opposite side of the lens compared to the object. The image formed is on the opposite side of the lens. Now when you see this, we can say that the image is real. Only the real image can be formed on the opposite side of the lens. Now, how about the orientation? The light rays is coming from above the principal axis. So this is your principal axis. Right, the light rays are coming from above the principal axis. And after passing through the lens, it converges below the principal axis. So in this case, we can say that the image is now inverted. Okay, the image is formed on the opposite side of the principal axis and is now inverted. How about the position of the image? Now, as I said earlier, the object is located very, very, very far away. And yet, in fact, so far that it can be considered the object distance is infinite. And in this case, when you look at the ray diagram, the image is actually formed on the principal focus. And how about the size? Size may be a little bit challenging to see, but because the object is located very, very, very far away, it's very difficult to illustrate in the diagram here. but you try to picture this, the the object has to be located so far that by the time the rays come to the lens, it's almost parallel. I mean, in fact, it can be considered parallel. So that means the object has to be very, 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 very big. So in this case, when you talk about the size of the image, you're actually comparing the size of the image to the object. And since the object is very, 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 very big, the image is considered diminished. Or if you don't like the word diminish, you can say reduce in size. But please learn the word diminish because I'm not so sure whether they will test you in the MCQ. But if you say it's reduced in size, it's also accepted in O levels. So you don't have to worry about that. Or any way of phrasing that the size of the image is smaller than the object.